Good morning, students. In this video, I would like to discuss with you about master slave JK flip-flop. Before going to master slave JK flip-flop, let us have a review about JK flip-flop. JK flip-flop has two inputs J and K and two outputs Q and Q dash. And we are interested in two states, set state and reset state. When J is equal to 1 and K is equal to 0, it is called a set state. And when J is equal to 0 and K is equal to 1, that is called a reset state. And we have one more state. J is equal to K is equal to 1. That is called toggle state. It's a change its previous state. This condition is called a racing condition. So in order to avoid that racing condition, we are using master slave JK flip-flop. So racing condition, when J is equal to K is equal to 1 and high clock, the output will toggle. So that condition is called racing condition. This is the logic diagram of master slave JK flip-flop, in which we are using two JK flip-flops. The major differences between these two flip-flops are: first one is using a positive trigger clock pulse and second one is using a negative trigger clock pulse. Therefore, we are connecting a NOT gate in between the clock pulses of first and second JK flip-flops, and the output Q of the first flip-flop is connected to the input J of the second flip-flop, and the output Q dash of the first flip-flop is connected to the input K of the second flip-flop, and the final output is fed back to the input Q fed back to J and Q dash fed back to K. So one is act as a slave and the first two flip-flop act as master. Therefore, it is called a master slave flip-flop. So from the figure, it is understand that in the positive clock cycle, the first master flip-flop get activated and the slave flip-flop is inactivated. And in the negative clock pulse, master get inactivated and slave get activated. So the output from Q and Q dash from the slave flip-flop are fed back to the input of the master. The output of the master flip-flop being connected to the two inputs of the slave. That is all we discussed in the previous slide. So the first flip-flop is called a master and it is drawn by the positive clock cycle. Second flip-flop is called slave and it is driven by the negative clock cycle. During the positive clock cycle, master is active and slave is inactive. Master flip-flop gives the intermediate output, but the slave flip-flop is not give the final output because the slave flip-flop is activated only in the negative clock cycle. During negative clock cycle, master is inactive and the slave is active. Slave flip-flop get activated and copies the previous output of the master flip-flop and produce the final output. So the purpose of slave is just to copy the outputs of master. So this is the logic diagram. I already discussed the block diagram of master slave JK flip-flop. This is the JK flip-flop and this is the second JK flip-flop. We can club it together by connecting the output of first JK flip-flop to the input of the second. Then the major difference is we are connecting a negative clock to the second flip-flop. So you can easily understand the logic diagram. So this circuit accepts the data only when the clock signal is high and passes the data to the output on the falling edge or in the negative clock cycle. In other words, master slave flip-flop is a synchronized device as it only passes data with the timing of the clock pulse. When the clock is slow, the output from the master flip-flop are large and any additional changes to its input are ignored. So, when the clock pulse is low or during the negative triggering, the slave get activated and the master get inactivated. Therefore, the additional changes to the input get ignored. So remember, the slave just copying the output of the master. So when J is equal to K, we know it's a set state for JK flip-flop. Master responds to J and K input before the slave. If J is equal to 1 and K is equal to 0, the master set on the positive clock edge. The high Q output of the master drives the J input of the slave. So when the negative clock edge hits, the slave reset, copying the action of the master. So when J is equal to 1 and K is equal to 0, this JK flip-flop will be in this set state and we will get Q is equal to 1 and Q dash is equal to 0. But this second slave flip-flop is inactivated, so we don't get any output or we don't get a change in the output. When J is equal to 0, K is equal to 1, that is called a reset state. Master goes to reset state during the positive edge of the clock. The high Q output of the master goes to the input of the slave. Therefore, whatever may be the output, it just passes to this slave. The arrival of the clock's trailing edge or the negative edge forces the slave to reset. Again, the slave has copied the master. That means when J is equal to 0, K is equal to 1, that is called a reset state. So the output of this first master flip-flop is Q is equal to 0 and Q dash is equal to 1. But it is an intermediate state, and during the next negative clock pulse, we get the final output. Therefore, remember, slave is active only in the negative clock pulse. So during the positive clock pulse, we get a intermediate state here, but in the next negative clock pulse, we get the final output. Then when J is equal to 1 and K is equal to 1, the master cannot change its slave until the next positive clock pulse arrives. Thus, the final output will change once during each clock pulse and the racing is avoided. The important thing is, so this is the important thing about master slave JK flip-flop. We can avoid racing condition because in each clock pulse, in each clock pulse, the master is activated only in the high state of the clock and the slave is activated only in the low state of the clock pulse. Only during the low state of the clock cycle. Therefore, we can avoid the racing condition. Therefore, the master toggles once when the clock is high, and when the clock goes low, the slave changes state. This is the advantage of master slave JK flip-flop. Thank you for listening. Thank you.